In part 4 of our lesson on algebraically defined vectors, you will learn how to find the angle between two vectors. Take a look at this diagram. We have vector u and vector v have an angle of theta between them. It turns out that the cosine of theta is equal to this quotient, where in the numerator we have vector u dotted with vector v, and in the denominator we have the magnitude of vector u multiplied by the magnitude of vector v. So let's see how this works. In this example, we're given that vector A is negative 3i plus j, and vector B is 7i plus 4j, and we have to find the angle between vector A and vector B. Well, it's a great idea to start off by drawing a picture. So vector A being negative 3i plus j means that it will be over here, and we can write that in position vector notation if we like. Vector A is equal to vector negative 3, 1, we know vector B is 7i plus 4j, so that would be over here. And again, we can write that as vector B is vector 7, 4. So we have to find the angle between them, so this is what we are solving for. Let's call it theta. We know that the cosine of theta is going to equal vector A dotted with vector B divided by the magnitude of vector A times the magnitude of vector B. So let's find each of these. Vector A dotted with vector B, we know to do that, we take the product of the horizontal components, so negative 3 times 7 plus the product of the vertical components, which would be 1 times 4. So this is equal to negative 21 plus 4, which is equal to negative 17. So we can fill that much in. Cosine theta is equal to negative 17 divided by, now we need to know the magnitude of vector A. So we know that the magnitude of vector A is going to be the square root of the sum of the squares of its components. So negative 3 squared plus 1 squared. So this is the square root of 9 plus 1, which is 10. So we can go ahead over here, and for magnitude of vector A, we can fill it in with radical 10. Now we need the magnitude of vector B. So magnitude vector B is going to be the square root of the sum of the squares of its components. So that's going to be 7 squared plus 4 squared. So that will be the square root of 49 plus 16, which is 65. So we come back to our equation and we can fill in magnitude of vector B is radical 65. So now we have cosine of theta is equal to negative 17 divided by the square root of 650. We have to take the cosine inverse of both sides. So we have the cosine inverse of cosine theta has to equal the cosine inverse of negative 17 divided by radical 650. The left-hand side becomes theta, and the right-hand side, we have to do second cosine inverse of negative 17 divided by second radical 650, close the parenthesis of the radical, close the parenthesis of the cosine inverse, and we find out that the angle between them is 131.8 degrees. And when we look at our drawing, this makes sense because from our sketch, we could see that theta was going to be an obtuse angle. Next, we're going to discuss orthogonal vectors. Two vectors are orthogonal if the angle between them is right. So looking at this diagram, we have vector u and vector v have a right angle between them. So because theta is a right angle, we would say that vector u is orthogonal to vector v. And notice that this is just like the perpendicular symbol you used in your plane geometry class. So you may use this symbol for the word orthogonal. Perpendicular refers to lines in a plane where vectors can be in three-dimensional space, and we use the word orthogonal. Now remember, we just learned an equation that will find the cosine of theta, and cosine of theta is equal to vector u dotted with vector v divided by the magnitude of vector u times the magnitude of vector v. Now remember, when we're talking about the size of something, that's always positive. So the magnitude of u is always going to be a positive number, and the magnitude of v is also always going to be a positive number. So the denominator is always positive. So then that means the positive or negative sign of cosine theta depends only on the positive negative sign of the dot product. Since the denominator is always positive, then if the numerator is positive, cosine will be positive. If the numerator is negative, cosine will be negative. When we're finding the angle between two vectors, we know that it could be acute, or it could be a right angle, or it could be obtuse. Now, if it's an acute angle, we know then that means that cosine theta had to be positive, because in quadrant 1, cosine is positive. And if it's an obtuse angle, we know that cosine theta will be negative. Now, if it's a right angle, think about that. What does that mean cosine had to be? If it's a right angle, we know that the cosine had to be 0. Cosine of 90 degrees is equal to 0. Now let's put this all together. If the dot product is positive, we know that means cosine of theta will be positive. Because remember, in our equation, cosine theta is equal to vector u dotted with vector v over the product of the magnitudes of the vectors, which are always positive. So the positive and negative sign of cosine is going to be controlled by the positive and negative sign of the dot product. So if the dot product is positive, that means cosine is positive, which then means theta is acute. We saw here that when the cosine is positive, we're getting an acute angle. Another way to think of this too, of course, is using the inverse cosine. We know cosine inverse of a positive outputs an angle in quadrant 1, and cosine inverse of a negative outputs an angle in quadrant 2. Now, if the dot product is negative, we now know that means that cosine theta is going to be negative. If cosine is negative, that means we'll be taking the cosine inverse of a negative. That's going to output a quadrant 2 angle, so theta is obtuse. And if the dot product is equal to 0, that means cosine theta is equal to 0. And we know when cosine is equal to 0, that's going to be a right angle between the two vectors. So theta is right. So now we can take this fact that when the dot product is 0, theta has to be right, and we can use that as a test for orthogonal vectors. So if vector u dotted with vector v is equal to 0, then that means vector u is orthogonal to vector v. So let's try using this test. In this example, we want to determine if the two vectors are orthogonal or not. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. So we know that all we have to do is look at the dot product. If the dot product is 0, the vectors are orthogonal. If the dot product is not 0, then the vectors are not orthogonal. So in this first one, we have vector A dotted with vector B. We know the dot product says multiply the horizontal components, so 12 times 10, and add that to the product of the vertical components, negative 5 times 24. 12 times 10 is 120. Negative 5 times 24 is minus 120, which equals 0. So since the dot product of the vectors worked out to be 0, we can say, therefore, vector A is orthogonal to vector B. In this next problem, we have to look at the dot product of vector x with vector y. We know we have to take the product of the horizontal components, so negative 3 times negative 5, and add that to the product of the vertical components, so 6 times negative 2. Simplifying, we get 15 minus 12, which equals 3. Because this is not 0, we have to say, therefore, vector x and vector y are not orthogonal. So this is a pretty easy test to do. If the dot product is 0, the vectors are orthogonal. If the dot product is not 0, the vectors are not orthogonal.